So I just want to do a quick little tutorial of 3DR showing kind of how I would go about cleaning the point cloud. So here I've got the same E57. Well, I guess not this one you had, but I created the E57 from the same skins you guys had, same control. So I'm just going to go and import this in. E57s are always defaulted as meters. So this file's 9.85 gigs in total, a little over 500 million points. So best I can, I'm going to try to do all this live, try not to speed it up just to show real time what it takes to clean the data set to ultimately get to the deliverables that you guys are looking for, from elevation mapping, contour lines, spot coordinates on a grid, etc. So we'll just kind of work through it and just kind of follow along, or watch as you like, speed it up as you like, go from there. Cool. So here is the cloud. Before I start, right now it's still currently in the real world coordinate system. Just for working with it, I'm just going to go create a quick temporary 2-point. So it's just going to align it up to plan north. Just use this concrete edge. So now, nice and squared up. So step one, I'm just going to come in, do a quick little manual clean just to isolate to more or less the slab that I want. Don't have to get super perfect, just trying to get rid of the majority of the junk that I don't need, at least for the sake of this demo. So you can do this as fine tuning as you want, as much detail, zoom in and out, all up to you. Go from here, so I'm going to go just cut off all of this kind of stuff here. Not sure if it's like a Jersey barrier, just dirt, but okay. All right. Enter, go select the points. I'll just split them up into kind of a couple groups of points of stuff that I don't need. Split. And so now we'll do a quick elevation view. All right, just kind of rotate my view. Okay, just so I see or for the bottom of concrete, just so it's all even. So I'm kind of aligned with the slope of this slab. Try not to cut off the rotunda bases, because I think I remember seeing some deliverable or some information in there from you. All right, how does this look overall? Decent starting point. So I'll just merge the split points. So now, and I can delete them if I want, but I'm not going to. I'm just going to keep them as is. So next step, since there's a lot of moving stuff, and again, from Register 360 or my registration software, I did zero cleaning whatsoever. So we're going to go in the clean tab, we're going to go moving objects. Just leave these as default values, usually does a pretty decent job. So if I really wanted to, I could change this threshold to a smaller value. Take a little bit longer, but I should try to do a little more accurate, better job of kind of identifying move points. So here we can kind of see difference before and after move points, unmoved points. So we'll hit OK. Not too bad. And so with this, let's just expand this out. So just keeping all the points are separating out separate, just to kind of show you before and after, once I kind of get done cleaning some of the cloud. So at this point, a couple more filters I want to go and run, because I think we have just a few handful of like outlier points, random noise, reflections, just bullshit that's below the slab that we want to make sure we're removing, so when it comes to the surface model creation, that it doesn't get caught. So I'll run a distance filter, which is basically just going to be it's going to identify points that are isolated, split, or basically from like the main group of points. If my main slab, continuous slab, if all the points are within half a feet of each other, they're not going to get picked up. Any outliers, any random points that are greater than 6 inches from the rest of them, it should keep those, or should identify those, and I can split those, delete them. Just again, for the sake of my meshing and DTM, digital terrain model creation, that it's not going to get picked up and kind of throw off the mesh. So let that run, and then we'll see how it looks. All right, so everything in red is one continuous, and all these handful of miscellaneous points down below, those are separated, split out. Okay, so now I want to delete all these other guys. Control G, and then we will turn them off and just keep them with the rest of the original deleted points. So now, there's other tools you can go and use, but for the sake of creating the DTM surface modeling, I think this should get us to a pretty decent starting point. Try 1 foot fast. Let's see how this looks. So this DTM digital terrain model, essentially what it's doing is it's trying to find the lowest points and then creating a surface mesh from those lowest points. I could have done this right from the get-go, from the beginning, and it would work. It just might include a lot more than I need. And then again, some of the points that are kind of sitting down below might get included, and I don't want those because they might create little like cavities or craters within the surface model mesh, which you can still fix them. I just, being lazy, I want to do it first try and not have to mess with any of that. All right, give it a second to load. So now here is our mesh. So still a handful of little pucks or little cavities. Not totally sure if that's entirely from random points or if there's just a little bit of cleanup that needs to happen, but I'll give it a second to load. I mean, at this point, we're kind of splitting hairs anyways. If it'll finish. There we go. Alright. I'll just hit OK. Accept this. Still got some points that need to be cleaned up. Get rid of all of these. Okay. So, if I really wanted to, I could still come back in and let's see, clean. Nope, those are the move points. So if I wanted to, I could basically do a refinement, basically using the original point cloud. I could go have the software add more detail to the mesh as needed. Not going to hurt anything. Adds more detail, just adds a little bit of time more than anything. But at this point, we've got our surface model, surface mesh of the cleaned up ground, and then we can go and start to create a handful of different deliverables. So can just do a long direction, but let's just do surface levelness. And then actually before I do that, I want to make sure I'm in my world coordinate system again, just so that it doesn't mess with my elevations. Surface levelness, preview. So here is just a simple elevation heat map of this overall mesh. So you can still come in, you can change your colors if you want to do to a certain range, if you want to do steps of colors, kind of like you see how it got updated there. Whole list of different like tolerances if you know your sloping percentages or deviation analysis. lots of different ways you can colorize mesh point clouds, etc. So we'll just leave this as is. Looks good to me. So this is one. If I wanted to, I could have also created a spot coordinate elevation right from that surface levelness. Otherwise, if I wanted to do a manual one real quick, that looks something like this. So I want to do a gridded inspection, basically drop a spot coordinate, horizontal axis, just to define the basically direction to pull all these points on a grid. We'll do spacing. I think I saw in your deliverables it was 10 feet by 10 feet. Pass through. Just want to make sure that it goes all the way through. Okay, and preview. So now you're looking at just little spot coordinate elevation readouts on a 10 by 10 grid. So okay, and then I still got civil open. So a few things we can kind of do with this. Grid inspection will turn our mesh group, or well, let's turn this back on. So I got all these overlaid. If you wanted to, should also be able to send this directly to CAD, and then where'd it go? Might be missing a step, but we'll get to that here in a second. So I got your overlay, got a nice little mesh. If you want to do contour lines, we'll do step. Let's do, I don't know, contour line every 0.083 for every inch, every 5 major. And then just check it out. Doesn't look too bad. Happy with that. Contour. So again, here, if I want to go send this directly to CAD, so should be also set directly to real world coordinates, elevation, everything. And then a lot of these, I probably should have updated all of like the labels, the spacing. So might as well just do that quick. Delete those out. Let's see. I'll just delete it and start over. Contour lines. I want spacing. Let's see, where was it? Transparency, distance between text. Do distance between text every 20 feet. Text height 0.083. Okay. Oops. I forgot to change my step. Do it again. 0.083. Contours 3 feet. Okay. Maybe I'll do filter contours, get rid of anything that's less than 10 feet in length. Should get rid of some of the really small contours. Mesh transparency 2020. Okay, let's go send this to CAD. Now, should look a little bit better. So, got our text heights, all of that. Here's our contour lines. Pretty easy to go and work with. Okay. Also, let's see. So that was my contour group. Let's see. Can I send this directly to CAD? I think so. So then you got your tin surface, mesh surface, brought right in. Let's see. 2D wireframe shaded. So it's just going to be a standard plain old tin mesh surface, but all right into CAD. So if you want to do other deliverables directly in CAD, you absolutely can. Trying to think of what else you had within your deliverables. At any point, everything you do is always going to be captured in this kind of generic reporting template. So if you want, you can come in, you can create your own reports. You can go and update these 3D views. If you want to do, instead of a 2D, you can even do a 3D PDF with all of this. Same thing with the spot coordinates. Okay, you can edit, you can add different labels, tags, information. If you want to do just really simple, let's go turn on contours and get a nice looking little deliverable, or just at least snapshot. Change this back to unnamed. Let's go turn on our gridded inspection. So now I go to the view tab, capture view. Just want to go spit out a really nice high-res image. And where do I want to throw this? Training. There. Exported. Sample. All right. And you got a nice little elevation heat map, spot coordinates on 10-foot grid. You got contour lines overlaid. And you can just kind of edit these images, the view, however you want to show whatever information it is you want. So all sorts of tools to ways to go and clean the data to create really nice looking deliverables. And then just for fun, I'll spit out a 3D PDF. And we'll go just so you can kind of see what that looks like. Let's change this size of it. Okay. Okay. And let's send this to PDF. Scans 3D PDF. Hopefully this one doesn't take too long. So usually the 3D PDFs take maybe a minute or two to go and generate, but in any case, it should be fairly quick. It's only when you try to export out point clouds that it can be kind of slow. You really shouldn't export point clouds in 3D format, just meshes. And even then, you don't want to go too large of meshes. So, right in Bluebeam, and then kind of a fun thing, it's 3D. So you can change your page size, dimensions, and all that in 3DR. But then you're going to have a nice little 3D mesh viewer that if you got Adobe Creative or Adobe Acrobat or Bluebeam PDF, you can load them up. So, looks like the gridded inspection might not work. Never really tried that one in 3D PDF, to be honest. But either way, you got options and different ways you can go about spitting out these nice looking reports, images, exports to share with the project team. So all of this is just simple, really basic in terms of like what you can go and produce out of 3DR. I mean, there's a whole plethora of different things from, I select my point cloud, give it a second to reload, but surface levelness, flatness, slope analysis, you have ASTM floor flatness testing, whole plethora of comparison analysis, deviation analysis. If you got BIM models, surface models, topography models, whatever that's you can bring in. You can do all sorts of really cool, powerful deviation stuff, analysis stuff. You got 3D modeling tools if you want to go extract some basic shapes and structures and elements from what you're doing. It's not like you're modeling in Revit, but if you want to get generic shapes, you can absolutely do that. It's all contour lines. There's a virtual surveyor if you need to go produce as-built documentation. Points on a grid, Kogo points. There's 3D model pipe extraction if you guys get into that type of system. I mean, it's a plethora of tools and analysis extraction. And then I just kind of showed you just a couple of the multitude of different ways you can go about cleaning the point cloud data if you don't want to clean it within Recap, Scene, or Register 360. So that's all great. And then with your point cloud, after you clean it, if you really wanted to as well, you can come in and then you have a variety of different file formats for point clouds that you can go re-export out if you want to bring into other third-party software. So that goes for meshes. So like this mesh, if I want to spit it out to FBX, OBJ, STL, if I want to bring that mesh into Navisworks, you can absolutely bring the same mesh, colorized mesh, even with your deviation or elevation map, and you can bring all of that into Navisworks Revit just by linking in an FBX file or an OBJ, whatever file format you want with textured meshes. So a lot of really cool things you can do in 3DR, and it's all relatively quick and easy and not all that difficult once you know a few of the basic picks and clicks. So hopefully that helps and gives you a nice little understanding of kind of capabilities of 3DR and different ways you guys could potentially start to leverage it. So as always, if you got questions, just reach out to me. If I got time, I'll try to get back to you, get you back on Teams or whatever. So yeah, hopefully this helps. See you around.